Okay, so we're going to integrate now with direct application to finding the area under a curve. So what we're going to do is set up our integral where we're finding the area under this curve between -1 and 2, our lower limit -1, upper limit 2, and our function is e to the half x, and we're going to integrate it with respect to x, so dx. So now we've set up our definite integral. Now we'll use the result from the standard form that we've looked at previously because we've got this in the form of an exponential raised to the power that's a linear function. So the result will just be the 1 over the coefficient of x times our exponential plus c. If it was an indefinite integral, because it's a definite integral, obviously we don't need to worry about our constant. So between -1 and 2, using this result here, we've got e to the half x, and the coefficient of x is a half, so that becomes 1 over a half, and 1 divided by a half is the same as multiplying by the reciprocal of a half, so 1 times 2 over 1, so this will give us 2e to the half x, and between 2 and -1. So let's substitute our upper limit first, 2e to the half times 2, minus, and substitute in our lower limit of -1, 2e to the half times -1, and let's see if we can simplify this further. So that becomes 2e a half times 2 is 1, but we really don't need to include this 1 here. It's sufficient to just write that as 2e minus 2e, and then we've got a half times -1 becomes -1/2. Now remember, because we're talking about an area under the curve, that's the application of what we're doing here. We want to include units squared. Now we can also take out a common factor here of 2. So we're left with e minus e to the power of -1/2 units squared.